How we find new information on the web has changed dramatically over the past decade and a half. In this video, we will take a look at a couple of the key milestones in this evolution. In the mid-1990s, there was a huge explosion of information on the web, bigger than any in the past. It was getting increasingly hard to find the piece of information that you wanted, and that was when Google entered the picture. Google started as a research project in 1996 and has come a long way since to become the dominating search engine in the world with a market share of over 65%. But how does Google search work? It all started with an algorithm called PageRank. The concept is to rank a web page based on the network of websites on the internet. The ranking system is based on the links connecting the various web pages.
We do this with software programs called spiders. Spiders start by fetching a few web pages. Then they follow the links on those pages and fetch the pages they point to, and follow all the links on those pages and fetch the pages they link to, and so on, until we've indexed a pretty big chunk of the web.
Based on the network created by the spiders, PageRank calculates the voting score for each website. The idea for how to rank web pages is the same idea as measuring popularity. Instead of thinking of friendships as the way to measure popularity, what we're measuring is links on the web. When one web page has a link to another page, this indicates that it's more likely that the page is popular. Just like when someone has a friend, it's more likely that they are popular. So the goal of ranking web pages is to get a measure of how popular a page is based on the other pages that link to it. But you have the problem that not all links are the same. That is, a link from a page that's really important counts for a lot more than a link from a page that is not important. So if the New York Times has a link to your page, this counts a lot more than if your mom sets up a web page and links to your page. What PageRank estimates is if a web surfer started on any random website and followed the links, what the probability of ending up at a specific website would be. Therefore, a website with a high rank has a much higher probability of a random user ending up at it. Internet search has come a long way since Google PageRank first launched. Today's search algorithms are even smarter than before and consider factors such as a user's location, past behavior, and preferences of similar users. Google takes into consideration 57 different signals, including what kind of computer you're using, type of browser you're using, where you're located geographically, to personally customize your search results. For example, if two people, Scott and Daniel, both search Egypt, they would get very different results. Daniel on the right got no results regarding the protests in Egypt, whereas Scott's results were full of links related to the protests. This is a simple example of how much search has changed and will continue to change. As Eric Schmidt said, it will be very hard for people to watch or consume something that has not in some sense been tailored for them. In addition to personalized search results, today's internet users receive information they did not know they were looking for. Instead of waiting for a query from a user, recommendation systems try to predict the item or friend the user might be looking for proactively. Recommendation systems have become very popular in the last several years and can be seen everywhere from online retailers such as Amazon.com to media companies such as Pandora Radio. Although there are many different types of recommendation algorithms, one of the most commonly used is a collaborative filtering method. The idea behind collaborative filtering is that people often get the best recommendation from someone with similar tastes. In this simple example of a collaborative filtering system, users first rate different items such as videos, books, images, and games. Based on these ratings from other users who have similar preferences, the recommendation algorithm makes predictions for an item the user has not yet rated, in this example, a video. Based on the available data, the system predicts that the active user will not like the video. One well-known application of this algorithm is by Netflix. Netflix recommends movies to its members based on the user's previous ratings and watching patterns. This data is used to create a complex algorithm that helps Netflix predict what movies its members may enjoy watching. The more data the web-based company gathers on you, the closer it can predict your movie preferences. The system relies on collaborative filtering, plugging user information about a particular product into a mathematical equation. The equation then recommends other products the users may enjoy. In 2006, Netflix offered $1 million to the person or team that could take its customer data and create a model that can make a 10% improvement over its current model, Cinematch. Armed with a massive data set of over 100 million ratings, nearly 18,000 movies, and over 480,000 members, on September 21st, 2009, a team was awarded the grand prize with a 10.06% improvement over Cinematch. The winning team is actually a combination of 3 different teams, and the winning algorithm used the average of over 800 different algorithms. Thus, as the amount of data about customers increase, so does the complexity of these engines to get us better, more personalized results. Information discovery has come a long way, from developing better search results through PageRank to personalized search, and now getting information pushed onto us preemptively. With more data being captured about us every day, the future of information discovery looks both scary and exciting.